Now we move our focus more to the genetics and research teams here at B+LNZ Genetics. First up, we're hearing from Suzi Keeling, who I think was given a little bit of a hospital pass from Dan Breyer last night. So Suzi is the Head of Science and Research in B+LNZ New Zealand and has been with the organisation for 6 years, and she's overseeing the research portfolio. She's going to share an update on some of the farming excellence programs that are happening, and like me, Suzi shared with me on the taxi ride in last night that she's really looking forward to next week and going on holiday with her kids. Suzi.
You're good. All right. So good morning, everyone. Thank you for the opportunity to have a chat with all of you this morning. Apologies for my voice. Slowly getting it back after being a little bit unwell last week. What I'm going to do is just talk about two of our key programs in our research portfolio. But just to give you a sense of the diversity of what we've got in our research programs, as Sam already alluded, we have a number of initiatives underway for facial eczema and parasites and also animal welfare. We also have various programs that support climate change, preparedness and adaptation. And we've done quite a bit of work over the last few years in terms of understanding farmer resilience and social science aspects, so we can think about how we can better support our farmers moving forward. And we have also been doing quite a bit of work in terms of improving how we communicate our science and realising, that we need to think about how we better articulate some of the complex science that is involved, but also make sure that we're working with farmers from the very beginning, because this needs to be a co-developed process. It's certainly not something that we want to end up at the end of a particular research program and hand over the information and hope it's going to be adopted. So we really work very hard to foster those collaborations and partnerships right from the outset in terms of deciding, is this a priority piece of work for the industry? Is there going to be good uptake? What does that look like? And what do we need to do to make sure we get it right? So I'm now going to talk just a little bit about our Cool Sheep program, which no doubt many of you are fairly familiar with. So the Cool Sheep program is a partnership between breeders, government and industry. It's roughly a 3-year program, about $4.3 million. And essentially its aim is to give every sheep farmer, the opportunity to invest in genetic selection tools to reduce greenhouse gas emissions and while still increasing productivity. And this particular program is broken down into a number of smaller projects, the first of which is around making low methane rams available. The second focuses on tracking these low methane rams on farm. The third is around accounting for methane reduction, and the fourth is around outreach and awareness. So I'm just going to talk about a couple of those projects for you this morning. So in terms of the low methane ram supply project, there's certainly been a huge increase, and basically there's been more interest than there is current capacity. So there's been a huge uptake. Just over 22,000 animals have been through Ag Research's portable accumulation chambers, and this represents about 90 flocks being measured. So it's pretty impressive. And when we look at this a little bit further in terms of who's actually participating and interested in being involved in this work, we've got 50% of the 35 largest stud breeders in New Zealand being involved. And these stud breeders, if we further break them down, they contribute about 40% of rams to market. So the project's had quite a rapid acceleration in terms of those wanting to have their animals measured. And certainly if you're interested in knowing more about this piece of work, Cynthia Lawrence, who's just over there, you put your hand up, Cynthia. So Cynthia is the program manager, and there'll be an opportunity to have a chat with her today if you want to know a bit more about getting your animals measured in 2025. So the second project, the initial piece of work focused on essentially doing a survey, so looking to gather some information to inform and better understand the level of interest in low methane rams on farm. Now this survey, we had about 300 people respond, and there was industry interest from stud breeders for about 40% and commercial farmers about 25%. And industry willingness to register rams, stud breeders 61%, and commercial farmers about 40%. So now the next step in this particular project is to work out how we can develop a process to track ram sales and purchases. So shifting tack slightly now, but I guess one of the things to note is that the research that is delivered through the research team aims to wrap itself around all things genetics. So thinking about Sam's formula there, we want to make sure we've got good feed, good animal health and good welfare. So it all links through to genetics. So the program I'm going to talk about now is focused on a particular challenging topic, and that being facial eczema. So over the last few years, the research team worked quite hard to develop a program of work with numerous other people involved, from farmers, breeders and other industry partners. And a few months ago, we were successful in finally securing government co-funding. So it's been a monumental effort to get us this far, and sometimes I almost feel like it's still not quite real. But we've been able to now start to communicate more about this particular 7-year program. Our goal is to have at least 350 farmers involved. I suspect many of you have heard about the sheep poo epidemiological study that we've been running over the last facial eczema season. So with that, we had about 200 farmers already out there collecting samples every 2 weeks for us. So we're already well on our way to meet our target of 350 farmers directly involved in the program. Just a quick breakdown there of the finances, $9 million over the 7 years from B+LNZ, 8.3 from MPI, and in-kind contributions takes us to $3.4 million. And we've got about 14 industry partners who have all put their hand up to either provide access to field trials, samples, animals, helping us co-develop tools. So it's pretty impressive. And so I think on that note, whilst B+LNZ is incredibly proud to lead this program of work, we certainly can't go it alone. I won't go through all of the program partners and collaborators there, but hopefully that gives you a sense of the diversity of everybody that we were able to pull together. So I think it's fabulous recognition that the sector is united on this in recognising that this is a substantial challenge, and we have to bring some new perspectives to tackle it so we can produce some new solutions going forward. Now, this image here is one which is trying to represent what is a somewhat complex program. But I guess one of the things that, at the outset of designing this particular program of work was when we look back over history, there were kind of flurries of activity where there was investment in science to advance facial eczema. There was some work done in the 50s, then it all kind of stopped, then the 80s again, and it all kind of stopped. And so what we've now got is the opportunity to take advantage of some of the more modern science approaches and see how we can tackle what has essentially been a really old problem for New Zealand. Documented cases well over 100 years ago now, and it's not getting better, it's spreading. We really need to throw everything we can at it to see if we can produce some new tools and solutions going forward. So our first pillar of work is focused very much on fundamental science, so understanding the disease and the fungus associated with facial eczema. And one of the first new insights that we now have is that I'm sure those of you who are familiar with doing spore counts, so when you look under a microscope, we now know that we have multiple species of fungus there. Some produce a toxin, some don't. So using that piece of information now, our next step is to see if we can come up with a more targeted tool to inform risk on farm. So all of these bits of information will then start to be pulled together as we then think about, well, how do we get a better handle on the social, economic and wellbeing impacts associated with FE. Some of the preliminary work that our economic service team did identified the cost of the sector of $332 million per annum. And the work that we also did trying to understand the social impacts on farmers who live through this every season, it's horrific. There's no other words to describe the angst that those farmers feel in knowing that they don't have options to cure their animals. Everything we heard through the work that was done with ag research for that was farmers primarily care for their animals. So the devastation when you can't offer a cure is really challenging. So that is a huge goal for us, is to bring farmers with us on this journey and so that they feel at the end of the 7 years that they now have options to tackle facial eczema. I guess the other aspect of the program is, once we've got that fundamental knowledge, we've got a better handle on the impacts, both social and financial, is then we're casting the net really wide in terms of our discovery aspects. So not only are we doing work to advance an alternative animal-friendly test for Ramgard, but it's also wanting to better understand the mechanisms associated with the disease and what can we learn from that in producing new tools and solutions. We're also thinking about what are some alternative grazing management strategies that we need to be considered. We have a lot of anecdotal evidence about ryegrass being a challenge, but how do we go further than that and actually produce some good guidelines and give farmers some options? So once again, it's always thinking about what does research look like from a farm systems perspective. And it's the genetics, it's the feed, it's the animal health, but it's also making sure that we're supporting the farmers on the journey as well, and making sure that we're having really good conversations and listening to all of the expertise that's out there, because we certainly don't know everything. And the final one is then once we've gone through a process and we've got a number of things that are looking potentially promising, is to then say, okay, well, what are these ones that we're going to narrow down and do some more work on? So for that, we want to make sure that it's been championed by farmers, that we've got good farmer confidence, applicable to farm systems, safe for animals in the environment, robust, cost-effective and practical. And wrapped around that is a significant communication strategy and also having a dedicated farmer community of practice as well going forward. So hopefully that gives you a bit of an insight into some of our key programs at the moment. But if you're curious to know more, there's a number of the team here over the next couple of days, and we've got a few opportunities to come and have a chat. So the Pick and Mix workshops, you can talk to Cynthia about low methane genetics. You can come and have a chat with Catherine McRae from Ag Research and Cara Brosnahan, who's our principal scientist in animal health, and also myself about what we're doing in parasites. Sam alluded a little bit to that, but certainly our key focus is on establishing those partnerships globally because the New Zealand science funding system is quite limited. And so through those connections overseas, we're hopeful that there's going to be some opportunities to collaborate and partner with others. There'll also be an opportunity to hear about the FE tolerance test. So if you're keen to know more about that, there'll be a short session on that just to give everybody an update on where we're at. And finally, tomorrow at the field trip, if you're interested in knowing a little bit more about our Hill Country Futures program, there'll be one of the stations there. We'll give you an update on some of the work that Derek Moot did at the farm. And that's it from me, and my voice held out, so well done.
Thanks very much, Susie. So next up we have Jason Archer. Jason is B+LNZ Genetics, livestock genetics specialist, and I did see a new role pop up there on Sam's presentation, which I can't remember. But Jason needs no introduction to any of you. I'm sure as breeders you all know that the work he does. He's involved providing direction to both sheep and beef programs, delivering the key link between the science, data strategy and practical application of genetics across the industry. And Jason was telling me he's recently spent about the last 6 weeks offshore, so I think that's going to form the bones of his presentation today and what he's seen out in the world there. So, Jason.
Thanks very much, George, and good morning, everyone. It's great to be here. The last sheep breeder forum I attended, it was about 2 weeks after I started with Beef and Lamb, which was in 2021. It lasted about an hour before we got shut down with COVID rules. So we've already made more progress this morning. We've lasted longer already, so that's a positive thing. As George said, as part of my role and as part of other things that I do, I've spent a bit of time, I guess, offshore, particularly in the last 5 or 6 weeks, but also last year. And so really I just got asked to sort of maybe give some overviews or some highlights as to what's happening in genetics internationally. And I think it really is important that we do continue to keep our eyes up and looking outside of our country. And I guess I can just say that from personal experience. When you do go out there, you see new things, you see what other people are doing, you see some areas that we maybe lead the world in and other areas where we're following. So I think it's really important. We do have one international guest here today. Dan Brown is looking out the window, I think, at the moment. But Dan, do you want to stand up and give everyone a wave, just so everyone knows who you are? And you can go and talk to Dan afterwards. So Dan is essentially heads up Sheep Genetics Australia, so our cousins across the ditch, and does some really interesting stuff, obviously. And you know, we talk quite a bit about what our respective organisations are doing, and really keen to continue with that relationship. So, yeah. So I'm just going to briefly run through a few topics, and they're really just highlights. So I'm going to talk a little bit about genomic technology and evaluation techniques. So that's the real geeky type stuff, which you probably don't need to know about, but I'll just tell you what the implications of them are for you. I'll talk a bit about some new tech and AI type stuff. I will talk about what are the topics of conversation in the US beef industry, and some of this will be more beef-centric than sheep-centric, and I apologise for that on a Sheep Breeders' Day, but that's what you see when you go, well, partly some of that was a couple of the purposes for my trip, but also the beef scene globally is a lot larger than the sheep scene. I'm going to talk about feed intake, and then I'm going to talk about what I don't really want to talk about is methane, but I am going to talk about it because there is so much out there that if I didn't talk about it, I'll be misrepresenting what I see when I go out there. So I'll make a couple of comments about that. But first, genomic technology and evaluation techniques, and that's the stuff that we do sort of inside and some of our partners do, the labs do. So where is this going? Well, there's a couple of things coming down the pipeline. Some of these are pretty close to us, and we'll talk about them. So the first one is what's called low-pass sequencing, and I am not the gene jockey. There's some people in the room, particularly agri-research scientists here, that know a lot more about this stuff than me. But essentially, it's essentially the next generation of. At the moment, you do a genotype. It gets sent off and they use what's called a SNP chip, and you've all probably seen a SNP chip. This is just the next generation of technology that will essentially do the same thing. Why does it matter? It's going to be cheaper in the long run. So I'm looking at John McEwen sitting right here in front of me. Is that right, John? And by how much?
Well, the first thing is that for high density, we used to have high density chips. That stopped a year ago, and low pass whole genome sequencing is now being implemented.
Can everyone hear, sorry? Yeah, so I'm putting you on the spot, John. I didn't even give you any warning, but it's more fun this way.
So to confirm, he didn't give me any warning.
You just sat in the wrong place.
A year ago, the high density SNP chip was discontinued, and the international community, Shannon Clark leads that stuff, said that they'll use low pass whole genome sequencing, and that's actually being implemented now. Ag Research or Genomes actually introduced a technology that was called genotyping by sequencing in the deer industry, I think in 2016 or 2017, so nearly a decade ago. So you could say they've already got the jump by a decade. That's about enough I need to say.
Righto. John didn't say how much it was going to reduce your price by. And I was going to say, whatever he says, double the price because it'll be double what he says. But go on, John.
A high-density chip used to cost about $185 per sample, and low-pass whole genome sequencing is probably $80.
Yeah, so that's the sort of order of magnitude that we hopefully are talking about. So that's a good news story, and it's coming, and it's sort of here at that end of the scale, but it'll work its way through the system, we hope. So that's what's happening out there in the genotyping thing. This is a good slide. I sit there and listen to people talk about mixed model equations, which is all this stuff up there. I don't actually understand what most of that means, right? So I just try and get the take-homes, and I I just put it up there just so it's something to look at and think, what on earth are these people talking about, right? But this is the basis of the single-step evaluations that we do. And there are people, single-step was probably, as a technique, was invented probably 10 to 15 years ago, but it's really only became implemented commercially probably maybe 8 to 10 years ago. And there are people still out there working on refining it, making it better, making it do more things, making it more efficient, etc. I only mention this because there are a heap of people doing this. They're doing it in dairy cows, they're doing it in all sorts of other areas. What can we get from it? So this is just a spoiler alert for tomorrow morning, when we're actually going to tell you about a major step forward that we've actually made. And Michael Lee and the science team, but particularly Michael, gets all the credit for this because he's probably the only person in this room that understood that last slide. So he's been working away, implementing the next generation of single-step technologies, and it's actually quite transformational in terms of what we can do. So make sure you're awake first thing tomorrow morning when we talk about that, and yeah, it's pretty transformational. So that's probably enough to say about the technical type stuff. There's a whole area out there in terms of new tech and artificial intelligence, and you'd have to be living on the moon to not have heard about this stuff and how it's going to affect your daily life and all that sort of thing. I'm just going to give you a couple of instances of what some companies are working on, and it's not here yet. It's a little way away, but it just gives you a flavour of what might be done and what I see when I'm going around. So this was a presentation which was given in the Beef Improvement Federation conference in Canada last July by a company called One Cup. It's a Canadian company. And it was really about using AI and visuals. So it was all based on, like the cheap security cameras you can buy to hang outside your house. So they're putting these cameras up and watching animals and scoring animals on different things. And she was talking, the CEO, she was talking about all the technology that goes in behind this and how they train the computer to map these animals. And this is a horrible looking picture of an animal, but this is what they do. So they've mapped that animal, the computer's recognising different parts of it. Now it's recognised its ear tag, and then it's going to go through in a minute, and it's going to start actually mapping how the animal's moving, the different parts of its legs, its locomotion, and yeah, see, it's starting to map the actual structure of the animal, how it's moving around, what's going to happen. So this is the sort of stuff they're working on. And this is the value proposition slide she put up. Now, take it with a pinch of salt because I don't think everything's going to work here, right? So she says she's going to measure feed efficiency. I don't believe that, and I've got a background in feed efficiency. I don't think you can measure it by just looking at animals eating as to how much they're eating. But there will be a whole lot of things that this sort of technology can do, and at this conference we had a bunch of people, bunch of the New Zealand Breed Society's reps that came up with us. Russell Prophet was there, Robert Peacock was there. It was probably in some ways the most sort of forward-looking type technology that we saw out there. So there will be a value proposition, and maybe one of the simple ones will just be measurement of structure, or possibly things like body composition. So they're actually looking at how to measure structure with this using photographs. There are scoring systems already out there that we have people scoring, but we might be able to do this with artificial intelligence soon. So this video she showed, you probably can't see because it sort of goes almost too fast, but every time that little white thing comes up, it's looking at the hooves of those animals and giving it a structural score on I think it's the claw set that they're looking at there. So just one of the sort of things that might be able to be automated in the future, and there are a heap of applications that this could be done with. Lameness was another one, so looking at the way the animal was moving, and lameness. Obviously, that's probably more a dairy cow thing than a sheep thing. Although we all get the odd limping sheep, eh? So that was what we saw in Canada last year. This presentation here, I saw at the ICAR conference just a month ago or 6 weeks ago, and this guy was actually an academic from a university in Italy, and doing stuff. Now the reason why I like this is my colleague David Campbell has this dream of being able to look at an animal and see its EBVs through your glasses, and I sort of roll my eyes a little bit. I don't do it visually, like I'm trying to be polite to him, right? But inside I roll my eyes and think, oh, why do I need to see this? Well, I've probably got to eat my words, right? Because this topic is getting pretty close to it. This guy was talking about how we use how we could potentially use some of the new augmented reality, and I don't understand all the technical stuff, mixed reality, I can't even tell you what that is. But there's these devices out there, right, that kids are using for gaming and all sorts of other things, and how could we use them in the future? And he was inventing stuff to do that with. So this is his concept, right? And he's created what he had was a glove, and the glove had the EID reader embedded in the glove, and it had one of those little, what do I call it, haptic things, you know, the way your phone buzzes or vibrates or whatever, so I had one of those in the glove as well. He was actually trying to then turn it into just a bracelet. So the idea is you're wearing this thing, and that's how you scan the animal, right? So you don't have to have this piece of gear in your hand, you just scan the animal, and then that was going to talk to this Bluetooth headset that you're wearing, and then that does voice recognition and exchanges data into a spreadsheet or a database just automatically. So that you are basically measuring your animals, working with your animals almost seamlessly, talking into this thing, and it's recording the data that you're scoring. A little bit out there. So this here is just a picture of a guy wearing one of those headsets, and essentially that's the vision that he can see. So it's brought up a bunch of things, including the ID of that animal and some key stats on that animal. So he's all doing that hands-free, essentially, and he'll be talking to it. And unfortunately, this was actually a video, but I didn't get the video, and on the conference website I could only get the still. But this guy was moving around those sheep, and he was basically just waving his hand over their head. I can't remember what he was doing, whether he was body condition scoring or udder scoring or something like that, but basically he'd walk up to the animal, put his hand near its head, and then go under, maybe udder score it, talk into the thing, and then that score, whatever he said, which was in Italian, so I didn't understand what the score was, would be automatically put into the database. So yeah, is it quirky or is it actually going to be useful? I don't know. But this is the sort of things that people are working on out there, that, you know, hopefully we'll see some useful stuff come out of that. Next topic, what are US beef breeders talking about? Well, they're talking about cow size and efficiency, finally, believe it or not. So the US beef industry is highly segmented, as most of you know. There's a cow-calf producer, there's a feedlotter, and then there's a processor and packer. They all want the things that drive their own business, and none of them care less about what the other person wants. But finally, this conversation is starting to say, well, actually, we've driven really hard, and from a geneticist point of view, we've been really successful in terms of improving product attributes and meat quality. And you know, they will say over there that in terms of their top grade of beef, the prime grade, it used to be a very rare thing. There's now sufficient animals getting into that grade that they can build brands and build marketing campaigns around that. So they've done a huge amount of work in that carcass quality thing, those market attributes. But the producers, the cow-calf producer, is finally starting to say, well, at what cost to us? So that's not news to anyone in this room, I know. Like, as Kiwis, who are sort of vertically integrated in a way, at least, you know, we keep our animals through, we understand the stuff, and I think we've understood it for a long time. How well we do it, I think we do a reasonable job of it, but yeah, this is really the topic of conversation at the conference I was at a few weeks ago, the Beef Improvement Federation conference. This was basically the headline topic for it. Cow size and efficiency. So not everything we do is behind the rest of the world, right? Sometimes we're ahead. The next one I was going to talk about is feed intake. Where do we sit? I get feed intake machine envy wherever I go, basically. Wherever I go, you see pictures like this. So the one on the left-hand side was a big feed intake facility, measurement facility that we saw. It belongs to ST Genetics in Houston, or just outside of Houston. And we're looking at these feed intake machines, and I was getting envy, of course. And then someone said, what's that? See that second picture? What's that box? Oh, I do have a pointer here, don't I? This little box here. One of the group said, oh, what's that thing up there? That was a camera that's weighing all the animals every time they come to eat. So it's basically taking an image, obviously. It's not literally weighing it, but with 96% accuracy. So it's pretty good. So yeah, some tech out there. The next picture was, again, another feed intake facility, and this was a multi-species one. So it's a Vitality feeding system, which is actually really designed for cattle, but they'd adapted it for sheep. So I see Tricia taking notes because she wants one of these, or something similar. Essentially, the adaptation was they'd build a ramp up the front so the animal can reach. Rather than have this great big bin of feed, they'd sort of made that smaller little bucket in there that you can see the sheep put its head in, and they just closed up the access a little bit so that the sheep couldn't jump on top of each other. Only one could feed at a time. But basically, the same technology was applicable to sheep as it is to cattle. So they had a great facility. Where else? I stopped taking pictures of facilities, right? Because I'm more interested in the animals than the facilities, and so I didn't actually have photos of this, but Dan Breyer and myself visited ABS Global. I didn't take a picture of the feed intake facilities. Those animals are just feeding out of a trough, but they had this big range of feed intake recorders. Those ones were manufactured in South America. We went to the University of Tennessee Research Centre, all those cattle there, and inside that shed is a feed intake recorder. Then we went to Ireland, and this is the Tully Bull Test Centre that belongs to ICBF. Big shed here, row of, 20 to 30 feed intake recorders that sort of underpins a lot of their feed intake work. And there's probably about 4 or 5 other places that I've been to that had facilities like this that I didn't even take photos of. One was Kansas State last year. They had a whole lot of Incitec feeders. So we're way behind. And that's an area that I'm pretty passionate about. We really need to get moving on in New Zealand, in cattle, but in sheep as well, which is why Tricia's taking notes, to put that other piece of the equation in, because around the world people have gone pretty hard and are now got established facilities, and they're old facilities too, to be honest. Like, none of these were brand new. They all look like they could probably do with being replaced. So yeah, that's probably just a message that we need to think about, and are keen to do. Oh, this was just another slide at the ICAR conference. It was a session on beef on dairy, and this guy was from Denmark, I think it was, and sort of casually said, well, we've got equipment to measure feed intake and methane. We can do 5,000 calves a year, etc., etc. So they're scaling up. They can do a lot of this stuff. And then finally, this is the topic I don't really want to talk about, but it would really be misrepresenting what's happening out there if I didn't say something about it. So methane is the buzzword at the moment, and it's more than a buzzword, right? It's everywhere, and it's a global effort. So these are some measurement facilities. The first 2 pictures are actually what's called a green feeds trailer. So this is a machine that sort of sniffs at methane. And in this case, you can, on the trailer, you can put it out in the paddock, and it has a high concentrate. It'll feed a tiny bit of feed to the animals just to get them to come to it. And you can measure methane every time the animal comes and has a feed from there. It sniffs basically the methane. They're really commonly used at the moment, but they're cantankerous things. They're hard to run. They've got a whole lot of technical stuff with them. The picture to the top right is AgResearch's answer to those. So Suzanne has had these cattle pack chambers, although P stands for portable, right? I don't think they're that portable. One of my colleagues in Australia decided that they should be called movable rather than portable. The picture on the right-hand side was at Tullian Island, and in the same pen with all those feed intake machines that I showed you before. That's basically a stationary version of what's on that trailer. So it's also a green feeds machine, but a stationary version. So that's just routinely implemented, and again, in terms of the research facilities, almost wherever you go, they're doing this stuff, and they're going pretty hard on it. So I think in terms of where we are in the world, in sheep, we're right up there. And that's thanks to the effort from AgResearch, but also Beef and Lamb invested in the pastoral greenhouse gas consortia a long time ago. Probably predates even your time as CEO, Sam, I think. 2003 was it? Yeah. So this has been in train for quite a while. Yep, it's not everyone's favourite topic. No, Beef and Lamb does not support paying a tax on this. But out there, it is fast becoming a market trait, and I actually really do think it will be used as both a market trait but also a trade barrier trait potentially. And just some examples. So we went to ABS Global. They were talking about their emissions reporting that they do as a company, scope 1, 2 and 3, and I'm not up with methane enough to really understand the ins and outs of all that reporting and the scope, and they were really, to be honest, just trying to get their heads around it. But they're reporting on what they do. They're owned by Genus PLC, which is based in the UK, so hence that. Every talk you go to at conferences, they're either directly about methane, and that might be 30% of the talks, 20% of the talks, but the ones that aren't about methane are all saying, well, here's the impact of what we're doing on our emissions. So that's almost part of almost every talk. So you talk about cow efficiency, cow size, and they turn it around and say, this is the impact on emissions intensity. So this is the conversation that's out there, right? I'm not trying to preach at you in terms of where we need to go, but that is the reality of the conversation that's out there internationally. Wool. Dan Breyer and I caught the plane over to the US and happened to bump into a couple of people from Wool Impact. So we went and had dinner with them. So you go to Chicago and have dinner with a couple of Kiwis. And they were over there to go to a big, what would you call it, sort of like an office commercial furbishment, I can't even think of the right word, but decoration, interior decoration for commercial buildings essentially. And they were talking about, there's buildings in Chicago with 2 floors worth of trade displays and all that sort of thing, and they're going to a conference. We started talking about the story that they're telling about New Zealand wool, and it's a great story. It's fireproof, it's its end of life story is great and all that sort of thing. Their one weakness is methane in terms of the story they can tell, and they're desperately searching for how they can tell that story about the methane product. It's nonsensical, right? We agree. We're trying to compete with this natural carpet product against recycled oil. So that doesn't make sense, but the fact of the matter is that is what's out there. So they were talking about the drivers for that, and it's really that the carbon footprint is being built into the building regulations. So everyone is asking them about the carbon footprint of their product because of the building regulations. So it's an unavoidable conversation that they were having, and they're desperately trying to work out what the story is that they can tell around that. They did tell us that when the life cycle analysis was done, and I don't know who decided this or how it was decided, but apparently 31% of sheep methane emissions were attributed to wool and the rest of it was attributed to meat. They didn't think that was very fair. There you go. It seems like quite a large number given the negative revenue most of us are making from wool at the moment. Emissions targets are baked into countries' legislations all over the place. So the reason we went to Ireland was really to look at the bobby calf issue, right? And what they're doing in beef on dairy. At the moment, Ireland doesn't have a significant bobby calf issue. They kill it was 30,000 last year, this year it's 15,000. It's almost nothing compared to our 2 million. But they are worried that they currently export about 200,000 calves, and those calves go to Spain and the Netherlands. And they're really worried that that is going to be shut down, possibly for perceived animal welfare reasons that Sam was talking about before. It might just be the ferry transporters just don't want the look, so that they run out of ferries to take them. But either way, they've got these 200,000 calves that go offshore, that they're worried about not being able to send them offshore. Their biggest worry in terms of the bobby calf and what they'll do, they said, no, it's fine, we can feed them, we can deal with them. Biggest worry is, what's it going to do to our national emissions profile, because we're all of a sudden feeding these animals in Ireland. And so at their national level, that's a big impact. They're trying to get their emissions down, they're having success. If we add another 200,000 animals back into that, that's a problem for them. I mean, it seems pretty artificial, right? Because those calves are going to go and get fed somewhere else. But that's the world we live in right now. That is the reality of it. And so, yeah, there is a global methane effort going on, a global effort to reduce methane. For us, I would really like to tie the conversation with methane into being able to get feed intake and feed efficiency information. And there's two reasons for that. Thanks, Kate. So there's two reasons for that. One is the science of it, right? So really, if we're going to deal with methane, what we've actually got to deal with is the emissions per kilo of feed intake. Not the intensity or anything like that, but we've actually got to make our animals more efficient. So that's the first reason. And the second reason is, let's get something useful out of this while we're doing it. So let's use the opportunity to get that feed intake data and to drive the efficiency. And there are going to be some spin-off benefits. So Suzanne and colleagues at AgResearch, and sorry if I'm stealing your thunder here, Suzanne, I don't know, are working on proxies for methane, right? So these rumen samples, and they look at the microbiome. Those microbiomes are predictive of feed efficiency as well as methane. That's right, Suzanne? Yep. So actually, if we take these microbiome samples, we'll get feed efficiency along the way. And really, I think that needs to be objective. So nice to see you back, George. And you'll be pleased to know that that was almost my last slide. No, there's three more. So I'm not a big Bill Gates fan, right? But I think this quote is actually pretty applicable, that we often overestimate what's going to happen in the next 2 years. So not everything that I showed you is going to happen in 2 years, right? But we often also underestimate what will happen in 10. So you think back 10 years ago and what's changed in the world since then, it's quite a lot. Just finally, I got asked to introduce the team that's here to you, just so that you know who they are. A lot of them you will probably already know, but I'm going to go and make them all stand up, right? So we're going to start with David Campbell, who's at the back of the room. Sarah, everyone knows Sarah. Where are you, Sarah? She's ducked out of the room for a minute. She's doing stuff, doing useful stuff, right? Cynthia, where are you? Oh, over there. So Cynthia was mentioned before. G is not here today. Sharon is a long-time stalwart, so there she is. Where are you? Victor's one of our newer staff members. Where's Victor gone? He was taking photos around here. He's disappeared. You'll see Victor around the place. He'll probably have a camera in his hand. Abby, where are you? Oh, she's on the desk. You saw Abby as you came in this morning, right? Becky, They've all disappeared on me. Oh, Becky is here, standing in the dark, down the back. Where are we? Michael. Everyone knows Michael. He's the man that understands those equations. Thank goodness someone does. Georgie, where's Georgie? Georgie's upstairs apparently. Laura, she'll be down on the desk down the front, I imagine too. Franzi's not here today. Gemma's not here. They both work more on beef stuff. Jim is waving his hand down the back there. So Jim's joined us from Palmer about 6 months ago. Anna's here. Probably most of you know Anna anyway. But Anna V is filling in for Anna B, while Anna B is on maternity leave. Sonia is not here today. She mainly does beef stuff. Dion is somewhere around here. She helps us out with all sorts of organisational stuff and make sure that we're doing stuff. And then Suzi, you just heard from, so needs no introduction, sitting somewhere. And Cara is one of our, here we go, Cara's down the back there. Also does a lot of our, basically putting together the programs around parasites and other stuff. So yeah, please make yourself known to those people and yeah, enjoy the rest of the day and a half we've got.
Thank you, Jason.
Go for questions.
So we've got a few questions rolling in for Jason. So first one here, RE feed intake. All your examples are grain, hard, feed-based. Any examples of feed intake technology for pasture-based systems like most of New Zealand? Yeah, it's actually really hard to do technically to measure feed intake of animals as they're grazing. Probably the closest we do is have those bins that were on the pictures, but use pasture-based type of silage, grass silage in those bins is about as close as we can get. There are people out there claiming to be able to do it with tags and measurements like that. They haven't shown us the data that shows how good they can do it, and until they do, I don't believe them. And the reason I don't believe them is I think a tag can probably do a pretty good job of measuring how long you eat for, the duration of eating. It might be able to measure how quickly you take bites, maybe, but I bet you it can't measure how big your bite is, and feed intake is one times the other times the other. So, yeah, like to give you a better answer for that, but that's the reality. Second one here, methane in wool. Is this measured on the animal or after shearing? Do different types of wool produce different levels?
So the methane in wool it's not actually in the wool, right? What I was talking about was when we do a life cycle analysis and we look at the whole the methane produced by the animal over its lifetime that's breathed out, how much is attributed to wool. And I'm not the expert in this area, so I can't tell you about whether it's, whether a merino gets a different attribution versus a crossbred. Yeah, I don't know, is the simple and honest answer.
Another one here. You talk about looking outside NZ for improving genetics, but getting genetic material from overseas is difficult and costly. What is Beef and Lamb New Zealand and MPI doing about it, making it more affordable and achievable? Paperwork and quarantine. Yeah.
So I was talking about looking at technologies to bring in, but yeah, the genetic material one is a difficult one, right? So we've got some barriers out there at the moment. I guess the biggest challenge at the moment, and I'm sort of only peripherally involved in these conversations, is making sure that in response to when, so we all know about M. bovis, right? It's here, and then there was a second incursion of M. bovis a couple of years ago, and that was almost certainly traced back to imported semen. Biggest challenge is to make sure that as MPI put in place their responses to that they don't effectively close down the border to semen importation, right? Because we absolutely need to be able to do that. More so in cattle, but in sheep too, I'm sure. And I know Sam sits on the governance group of that bovis response. You got any comment to make about that, Sam?
Yeah, it's just it is a really it is a really hard area in that, what are we going to end up spending? $800 million on that M. bovis response. At the same time, we do want genetic material coming to New Zealand. It does have a risk, and I mean the other aspect that plays into it, right, is around trade, and so there is this mix in terms of if we're restricting things coming into New Zealand, then other people use it as a barrier to us. So it's fair to say it's just quite a complex area in terms of how you balance all of those things in terms of the economic benefit to New Zealand.
Yeah, so we're probably, the short answer to the question, we're probably busy at the moment running a defensive action rather than an advancing action.
Another one here. Given the market density on SNP chips is going up and the cost of genotyping is going down, is BLG working on to integrate these SNPs into the evaluation engine?
Yeah, so are we working to integrate these SNPs in the evaluation engine? So yes, they already are. We take a subset of SNPs that go into the evaluation engine, and that is happening routinely. Michael, do you want to say anything about that or not?
Yeah, I can probably do. So I think due to the traits that we evaluate, there's probably little marginal benefit in increasing the density. There may be for some traits, but at the moment it's not a big priority. I think we've got bigger fish to kind of catch at the moment. But it is probably something in the future we may look at.
I can throw some comments on as well. But there is also an ecosystem of labs that we work with, and we need to ensure there's compatibility between the labs as well. So you'll hear tomorrow morning what Michael's talking about in terms of the updates to NZG that are pretty significant. So then it's really just looking at those incremental steps forward and access to the IP around the lab ecosystem that we've got and ensuring there's choice for breeders.
And one last question before we start to wrap up for morning tea. Given that New Zealand farmers on average are touted to only be capitalising on around 50% of potential genetic gains, is there potential for a beef and lamb campaign addressing the elephant in the room, feed your stock better, timing is everything? 16.101.
Yeah, absolutely, Jane. So I've got a slightly different equation to Sam. Mine says genetics, it doesn't say genetics plus, feeding plus animal health and welfare. Mine says genetics times feeding times animal health and welfare, right? Because if any one of those is zero, then the outcome's zero. So yes, absolutely agree. And that fits right in with Sam's strategy that he was talking before about getting back to on-farm profitability. In the genetics space, I'm really keen and have been for some time, but now that we've Sam talked about a new position to sort of take a more strategic view of this extension, and that's genetics extension, not general extension. So really keen that we get out there and do a lot more in terms of both engaging with you as breeders and helping lift all of our knowledge, and that's a two-way thing, right? But also then extending the potential of genetics, getting that message to the to your clients essentially as to how valuable genetics can be to their business and what difference it can make. But absolutely, if you don't feed the animals, then doesn't matter what genes you got, they're going to underperform. So they need to go hand in hand. So one of the things that Sarah and I talk about a little bit too is how you do this, because you need to get a base level of genetics knowledge into our heads, commercial farmers particularly. But then sometimes the genetics as the solution to a problem is almost better addressed as, here's the problem, be it parasite resistance, be it whatever, here are the 5 things you can do about it, and here's where genetics fits into those 5 things. So, yeah. And vitamin G is a big one in parasites.
Thank you very much, Jason.